Okay, so let's talk about some special parts of triangles. The two that we're going to talk about in this video are a median and an altitude and how they can be used in geometric proofs. The definition of a median is basically the segment from one of the vertices of the triangle to the midpoint and the side across from that vertex. So an example of that would be segment BX. Now, if BX is the median of the triangle, that means that X, the point that it intersects the opposite side, will be the midpoint of that side. Now, because there are three vertices in each triangle, we can draw three separate medians. But in all three cases, that point which the median intersects the opposite side would have to be the midpoint. So let's see how we can use that in a geometric proof. In example 3, we're given that QS is the median of triangle PQR, and we need to prove that PS, this segment, is congruent to RS, this segment. Well, it may seem obvious, but it's actually a three-step proof. First, using what the definition of median says, we can conclude that QS is intersecting this opposite side at its midpoint. Therefore, S is the midpoint of segment PR. Then if we use the definition of midpoint, we can conclude that the two segments, PS and RS, are congruent. So notice that even though it seems like a very intuitive conclusion, it actually requires some detailed explaining. Let's take a look at altitude. The definition of altitude is the segment drawn from a vertex which is perpendicular to the side opposite that vertex. Now, a very simple example is if I wanted to draw an altitude from vertex B in triangle ABC, I just draw a perpendicular line. If I drew it from vertex A, it would look something like this, and from vertex C, it would look something like this. Recall that the definition of altitude is actually somewhat intuitive because when we think about altitude, like the altitude of an aircraft flying, it's basically just its height, and we would measure height perpendicular to the surface that it is flying over. There are two other kinds of triangles that we could have altitudes in. In a right triangle, it turns out when I draw an altitude from vertex Y, it's going to be perpendicular to the opposite side. But when we have either of the two legs of a right triangle, when I draw its altitude, it's actually equal to one of the sides. That actually only happens in right triangles. If I have an obtuse triangle, I'll have one altitude that ends up inside of the triangle, but then I'll have two altitudes which end up being outside of the triangle.
Jiminy Jillikers, radioactive man!
That is why when we define altitude, it says that it is an altitude of a triangle is the perpendicular segment from a vertex to the line that contains the opposite side. In the circumstances of the obtuse triangles, the altitude actually ends up being outside of the triangle. So knowing that an altitude forms a perpendicular segment to the line containing the opposite side, let's see how we can use that definition in a proof. In example 2, we have given that angle CDA is a right angle. So I'm going to look at my diagram and identify angle CDA. Knowing that that's a right angle, I can apply the definition of perpendicular to conclude that AD is perpendicular to BC. And now that I know that segment AD is perpendicular to the side opposite vertex A, I can conclude by the definition of altitude that it is actually the altitude of triangle ABC. We're going to explore these ideas further at our next class, and I look forward to seeing you then.